One of the shortcomings of DHCP has always been the fact that it has a single point of failure. DHCP is not a fault-tolerant service. The old method for making DHCP reliable was to configure two different DHCP servers, but configure each one to lease a different range of IP addresses and ensure the numbers do not overlap. That way, it does not matter which server you lease an IP address from, you would have a valid IP address that places you on the network. A better method that we can configure now in DHCP is Failover. To look at Failover, I have RTS SVR1. So this is a second server. If I go to Tools, DHCP is in this list. But notice in DHCP, there is nothing configured. So I have no scopes on this second server. I'm going to switch back to my DHCP server, RTS-DC1. So this machine, RTS-DC1, is the DHCP server. Well, I'm going to open DHCP on this server. On RTS-DC1, I'm going to expand my IPv4 and I'm going to go to my Boston scope. When I right-click the Boston scope, there is an option to configure failover. In that configure failover, I have the ability to select individual scopes. So if I had multiple scopes here, I could decide which ones would be part of this DHCP failover. I only have one scope, so I'm just going to select all. Next for that, now it asks me who is the partner server. I'm going to type the name of that machine, which is LUN SVR1, which is RTS-SVR1. I'm going to choose next for that. I have two options now. I can put this in a load balance mode, or I can put this in hot standby. If I put this in hot standby, only the machine I'm on, RTS-DC1, will lease addresses to all my clients. It will actually replicate the DHCP database to the other server. The other server has a heartbeat, which is actually a ping, that goes back and forth between the two machines. If this server, RTS-DC1, goes offline for any reason while this is in hot standby, the other server will automatically start leasing IP addresses. Effectively, it makes the other server a backup server that's waiting in standby mode in the event this primary server were to fail. The other option is load balance. If I choose load balance, I can determine which percent of addresses each of these servers will actually lease. 50-50, 75-25, 80-20, whatever your goal is. I'm going to leave this on 50-50. The way this works, both servers run an algorithm and they agree based on a MAC address of a client which server should lease it an IP address. So the local server I'm on now, RTS-DC1, it will determine if your MAC address is between this range and this range, it's going to lease you an address. If your MAC address is between a certain range and another range, the other server will lease you an IP address. They negotiate that on their own. We are not involved in that process. We simply define the percentage of addresses. Now, I can enable message authentication. That is just a shared secret, which is equivalent to a password. I have to type in both machines. Here on my closed network, I don't have a need for a shared secret. So I'm going to just choose next for that. Finish. It tells me everything was successful. So I'm going to close that window. Now I'm going to connect back to the LUN. Now I'm going to connect back to the RTS Serve 1. I'm going to just refresh this screen. Now when I expand IPv4, that Boston scope shows up, where before I had no scopes on this server. There are a few ways I can tell that this is a replica. One, when I right-click the scope, there is an option to replicate the scope. If I made a change now, I could force replication. I also have the ability to deconfigure failover if I no longer wanted this to be a replica scope. So this is an easy way to make this a highly fault-tolerant service with no additional components to install, just the failover configuration.